Hi class, today we're going to switch over to some more geometry. Today we're going to be learning a lesson about something called the triangle inequality theorem. So take out your ISN and draw the line for Cornell notes, and let's jump right into it. So first of all, we need to figure out what the triangle inequality theorem is. So the triangle inequality theorem basically states that the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. Okay? So essentially what that means is that if we have a triangle with the sides A, B, and C, if we add side A and B's lengths together, the answer should be greater than the length of side C. If we add side A and C together, then the answer between those two should be greater than side B. And if we add side B and C together, then their lengths combined should be greater than the length of side A. And if all that is true, then it is a triangle, okay? If that's not true, then that means those sides cannot form a triangle, all right? So now let's jump into some examples. So for our first example, we want to know if it's even possible to have a triangle with the side lengths 7, 9, and 13. Is it possible for a triangle to have those as their side lengths? Well, let's apply the triangle inequality theorem. And here's a tip I want you to write down on the side. You want to definitely be sure that you add the two sides, start with two of them, add them together and see if they are greater than the other side, the remaining side. So, here's how I would solve this problem. I would first add 7 plus 9. 7 plus 9 is 16. Is 16 greater than 13, that remaining side? Yes, it is. So that checks out. Okay. Next, if I add 9 and 13 together, side 9 and side 13, those two equal 22. Is 22 greater than this remaining side? Yes, it is. So that checks out. Okay? And finally, if I add 7 and 13 together, I'll get 20. Is 20 greater than the side we didn't add? 9? Yes, 20 is greater than 9. So since this is true for all cases of all of the sides, we can identify that the side lengths do satisfy the theorem and that these three sides do form a triangle. Okay? So this lesson should be showing you that just because you see three numbers on a triangle doesn't necessarily mean that those sides will create a triangle in real life. So that's what the triangle inequality theorem is for. Okay? Now we're going to look at another problem. All right, for our next problem, we want to know if it's possible to have a triangle with the sides 4, 8, and 15. We're going to do the same exact thing that we did in the last problem. We're going to add two sides together and see if the sum of the sides is greater than the side we didn't add. So, if we add 4 plus 8, we get 12. But 12 is less than 15. Remember, we want whatever we add between two sides to always be greater than the side we didn't add. And since it's not, that means that we don't even have to go any further. We already know that the lengths do not satisfy the triangle inequality theorem, and therefore, these three lengths cannot form a triangle. Okay? So these are your two example problems. What you're going to do now is go on IXL and you're going to complete a practice activity. Make sure that you write down the problems, that you show your work, and that you work until you get 15 problems complete. Have a great one.